This video is about sketching a hyperbola given a hyperbola equation in standard form. Now let's just start out with a quick review of various types of equations for conic sections that you already have encountered. One type of equation looks like the following: x minus h, that quantity squared, plus y minus k, that quantity squared, equals r squared. Now this is the equation of a circle, and you would be able to read straight off from the equation that the center is located at h comma k, and that the radius for the circle is equal to r. And there's another equation that looks very similar, minor differences: x minus h squared divided by r sub x squared plus y minus k squared over r sub y squared equals 1. And this is an equation for an ellipse. And in some of the previous videos we've gone over drawing an ellipse based on an equation. Now this video, and the reason I'm writing this equation out immediately under the previous equation, is to show you there is one minor difference with major consequences for the sketch. The one minor difference between the equation for an ellipse and the equation for a hyperbola is that instead of adding the two terms, you subtract the two terms. Now this has major consequences with respect to the drawing, and we're going to go through a specific example to see how to create that drawing. So take as an example x minus 1 squared over 36, and then you know this is not an ellipse because it says subtract y plus 2 squared over 9 equals 1. Now let's figure out the center, looking back to the quantities next to the x and the y. The center for this hyperbola is going to be 1 comma negative 2. And further, looking at the quantities in the denominator, the 36 indicates that the x radius is going to be 6, and finally the 9 in the denominator underneath the y squared term indicates that the y radius is going to be 3. Let's try to begin putting all this together. Let's go find 1 comma negative 2, that's the center, and let's mark off the distance 6 to the right and 6 to the left. That's all the way out to 7, and all the way to the left to negative 5, and mark off the distance 3 above and below. And now we're getting into the meat of how to draw a hyperbola. What you should do to give yourself a guide is to create a rectangular box based upon those dimensions. I'm doing it in green right here. And that rectangular box, if you draw diagonals through the box, and let me get that straightened out, a diagonal all the way through the box, that diagonal is going to be what's called an asymptote for this equation. And let's put in the other diagonal. That is the other asymptote, almost finished. Now we can actually draw in the hyperbola. You go to one side of the box. That point right there at the end of the box is going to be a vertex of the hyperbola, and the hyperbola curves toward the asymptotes, and on the other end it will do the same thing. So in black, at the end result, there we have the hyperbola.